Chapter 5: The Application. Evolve or Die. Up to this point we have discussed the tools that you can use to build web APIs. We have discussed the fundamentals of the HTTP protocol, the basics of using ASP.NET Web API, and how the architectural pieces fit together. This is essential knowledge, but not the only objective of this book. This book is also about how to build evolvable web APIs. This chapter is where we begin to talk about how to create a web API that can evolve over a period of years, a long enough span of time that business concerns and technology will change. Rather than discuss the issues in abstract scenarios, we will walk the walk and build an API that demonstrates the concepts we wish to convey. This API will concern a domain that should be familiar to every developer and is sufficiently realistic that it could be adopted in real-world scenarios. Before delving into the details of the domain, we must ensure that evolvability is something we are truly prepared to pay for. It does not come for free. In order to achieve evolvability, where appropriate, we will apply the constraints of the REST architectural style. It is critical to recognize that we are not attempting to create a RESTful API. REST is not the objective, but rather a means to an end. It is quite possible that we will choose to violate some of the REST constraints in certain scenarios. Once you understand the value and costs of an architectural constraint, you can make an informed decision about whether that constraint should be applied to achieve your goal. Evolve. Ability is our goal. Before we can begin designing our web API, we need to define the building blocks for our application domain. This is part of the process that is so often ignored when people attempt to build distributed systems today. When you are building a classic browser-based application, the solution architecture is largely already defined. HTTP, HTML pages, CSS, and JavaScript all form the components of the solution. However, with a web API, you are no longer constrained by the choices of the web browser. A web browser may be only one of many different client components in the distributed system. With the building blocks defined, Chapter 7 will provide a sample API that assembles these components into a web API. These component pieces will be essential knowledge for building a client application in Chapter 8. By defining the reusable components independently of the API, we can build the client with the capability to interact with these components without needing to know the precise shape of the web API. However, media will allow the client to discover the shape of the API and adapt to changes as it evolves. Why evolvable? What exactly do we mean by an evolvable API? To an extent, evolve is just a fancy word for change. However, evolution implies a continuous set of small changes that can, over many iterations, cause the end solution to look unrecognizable to the starting point. There are a variety of ways that a web API may need to evolve over the course of its life. Individual resources may need to hold more or less information. The way individual pieces of information are represented may change. A name or a data type may be changed. Relationships between resources can be added, can be removed, or can have their cardinality changed. Completely new resources may be added to represent new information in the API. Resources may need new representations to support different types of clients. New resources may be created to provide access to information with a finer or coarser granularity. The flow of processes supported by the API may change. For many years, the software development industry attempted to follow the lead of more traditional engineering practices when it came to managing change. Conventional risk. Dom stated that change early in a product's development was many times less expensive than a change that occurred at later stages in its development. The solution was often to strictly manage change and attempt to limit it by performing extensive upfront planning and design work. In recent years, the rise of agile software development practice has taken us on a different path, where change is accepted as part of the process. Embracing change in small iterations allows a software system to evolve to meet the needs of its users. It is not uncommon to hear of websites that release new versions of their software many times a day. However, with web APIs, where the plan is to allow external teams to develop their own software to consume the API, our industry has regressed to its old habits. Very often the mindset is that we need to plan and design the API so we can get it right. Because if we make changes to the API that break the software, our customers will be unhappy. There are many examples of well-known API developers who have introduced a V2 API that required client applications to do lots of rework to migrate to the new version. SOAP is at least for all of the problems that people have had with SOAP-based solutions. It was at least honest in trying to control and manage change. SOAP was explicit in defining a precise contract between the consumer and provider of the API. It is the waterfall approach to integration. Do the work up front so that you can avoid change. This is in contrast to the many examples today of people developing systems under the banner of REST, hoping that it has some magical properties that make managing change easy. Unfortunately, they are just deferring the pain. Barriers to evolution. There are a few factors that impact the difficulty of dealing with change. One of the biggest factors is who is impacted by the change. It is very common for the consumers of the API to be a different team than the producers of the API. In addition, the consuming team often belongs to a different company than the producing team. In fact, it is likely that there are many consumers from many different companies. Implementing a breaking change can make lots of customers unhappy. Even when consumer and producer applications are managed by the same team, there can be constraints that prevent the client and server from being deployed simultaneously. When client code is deployed onto a large number of clients, it can be tricky to synchronize the updates of clients and servers. When clients are installed on knockdown machines, there can be additional complications, sometimes forcing client updates just creates a bad user experience. If a user wishes to use a client application but before he must apply an update, he might get frustrated. Most popular auto-updating client software applications download new versions in the background while they are running and apply on the next restart. This requires the server software to be able to continue to support the old version of the client for at least a short period of time. One of the challenging things about changing software is that some changes are really easy and have a very low impact, whereas other changes can affect many parts of the system significantly. Identifying what kind of change you are trying to perform is critical. Ideally, we should be able to compartmentalize our software so that we can separate the pieces that can be changed with minimal impact from those that have the potential for significant impact. As a simple example, consider making a change to the HTML spec. Ification versus adding a new page to a website. Changing HTML might require everyone to update their web browser, which is a mammoth endeavor, while adding a new web page to a site will not have any impact on web browsers. The web architecture has intentionally made this division to allow the world of website servers to evolve without users having to continually update the web browser clients. Change needs to be managed. It requires control and coordination. Any steps we can take to facilitate change over the long term will easily pay for themselves many times over. However, building evolvable systems is not free. There are definitely costs involved. What is the cost? In order to achieve evolvability, the REST constraints prevent our client applications from making certain assumptions. We cannot allow the client to know in advance about the resources that are available on the server. They must be discovered at runtime based on a single entry point URL. Once the client has discovered the URL for a resource, it cannot make any assumptions about what types of representations might be returned. The client must use metadata returned in the response to identify the type of information that is being returned. These limitations require building clients that are far more dynamic than a traditional client/server client. Clients must do a form of feature detection to determine what is possible, and they must be reactive to the responses that are returned. A simple example of this is a server API that returns an invoice. Assuming a client knows how to render plain text, HTML, and PDF documents, it is not necessary for the server to define in advance what format it will return. Maybe in the first version of the software a simple plain text invoice is returned. Newer versions of the server might implement the ability to return the invoice as HTML. As long as a mechanism exists to allow the client to parse the response and identify the return type, the client can continue working unchanged. This notion of messages that contain metadata that identifies the content of the message is called self-descriptive messaging. Additionally, when defining API specifications, you should specify the minimum detail necessary, not every detail. Applying Steen's wisdom of everything should be as simple as possible, but not simpler. Over-constraining an API will increase the chances of change impacting larger parts of the system. Examples of over-specifying include requiring pieces of data to be provided in a certain order, when the order is not important to the semantics of the message. Considering data as required when it is needed only under certain contexts. Constraining interactions to specific serializations of platform-defined types. The following two sidebars describe real-life scenarios that demonstrate how being overly prescriptive can have a negative impact on the outcome. The wedding photographer. In this real-world scenario, you'll see how contracts can be written to adapt to change. Compare the following two sets of instructions from contracts provided by a bride to her wedding photographer. 1. We would like to have the following photos. Bride in and outside church. Bride and groom on church steps. Bride and groom by large oak tree in front of church. Bride with bridesmaids in front of duck pond. Groom and best man by the limo. 2. We would like some photos that can be given to family members with us and their relatives. We also would like other, more personal photos for us to decorate our house. We would like some photos to be black and white to fit the decor of our living room. We prefer more outdoor photos than indoor. The contracts differ in that the first is very prescriptive but provides no explanation of intent. The second is more flexible but still ensures that the customer's needs are met. It allows the photographer more creative freedom, which will help him adapt when the wedding day comes and he finds the large oak tree has been chopped down. Or the limo is parked on a busy street where background traffic cannot be avoided. In the following example, instead of simply stifling creativity and producing an inferior product, the result completely fails to satisfy the original requirements. The will with intent change is inevitable, and making precise decisions today may invalidate them in the future when circumstances change. Consider the mother of 4 who is writing her will. She loves her children dearly and wishes to help provide for them when she passes, as none of them are particularly comfortable financially. Unfortunately, Johnny has a gambling problem and she does not want to throw money away. She chooses to write Johnny out of the will and distribute her wealth evenly among the other 3. Sadly, she has a stroke and falls into a coma for several years before passing away. In that time, Johnny quits gambling and starts to clean up his act. Billy wins 10 million in the lottery and becomes estranged from his family. Jimmy loses his job and is struggling to make ends meet. The will specified by the mother no longer satisfies her intent. Her intent was to use her money to help her children as best as possible. Billy doesn't need the money, but Johnny could really use it to help him get back on his feet. But the will is very precise on how the money should be shared. By choosing wording that would provide more flexibility to the executor of the will to meet her intent, the mother could have made a significantly different impact. We often see similar results in software project management, where customers and business analysts try to use requirements to precisely define their envisioned solution, instead of capturing their true intent and letting the software professionals do what they do best. The contracts we use when building distributed systems must capture the intent of our business partners if they are going to survive over the long term. The combination of runtime discovery, self-descriptive messaging, and reactive clients is not the easiest concept to grasp or implement, but it is a critical component of Evolvable systems and brings flexibility that far outweighs the costs. Why not just